Okay, so today, as you can see by the title of the notes, it says review. We've already worked with adding, subtracting integers, but it is quite clear that it is not going very well without a calculator. So we are going to spend a day on this, and we have got to learn this. Say that to yourself. I have got to learn this. There is no choice. You cannot be counting on just, putting an answer down and hoping for it to be right. We need to know how to do this, and we can't be calculator dependent, letting it calculate. We have to have an understanding of why the answers should be what they are. So today we are going to review adding and subtracting integers, and we're going to use addition rules because we will always, notice I put a box around the word always, change subtraction to what? Add the opposite. Fill in those blanks to add the opposite. It does not say sometimes. It does not say when the temperature is above 0. It does not say when you are feeling good. It does not say if you have red hair, even if it's not natural. It says always change subtraction to add the opposite. Okay? So let's practice that. 5 minus 8. Underneath it, we're not going to change it right there. We're going to change it underneath. So if you've already done that, erase. Underneath it, we're going to rename that expression as, does the 5 change? No. We're going to change our subtraction to addition. What is being subtracted from 5? No, what is being subtracted from 5? No, what is being subtracted from 5? 8. 8 is. Now we say, what is the opposite of 8? Negative 8. Okay, that's all we're going to do. We're just practicing changing subtraction to add the opposite. Right now, I could care less what the answer is for that. But just in case anybody knows, you want to show off? Caden? Negative 3, you're right. Okay. How about the next one? Negative 2, subtract 6. How's it going to start? Negative 2. That first number is not going to change. The subtraction is going to change. What is being subtracted?
6.
6. What's the opposite of 6?
Negative 6.
Negative 6. Okay, somebody else want a chance to show off? Not Katie here, but somebody else. Sylvia? Negative 8. You are so right. Okay. The next one. Should the 4 change? No. Change that subtraction to addition. What is being subtracted?
Negative 1.
Negative 1. Are you here, Caroline? Yeah? Okay. Negative 1. What is the opposite of negative 1, class?
1.
1. Okay, I want everybody participating. Okay. Why don't you all show off? 4 plus 1 is?
5.
Thank you. Okay. So now let's go through the adding rules. This is where we really need to start being able to process what's going on, not just get answers, okay? So adding rules. Here's the first one. What sign is the answer when we add two positive numbers? What sign will our answer be when we add a positive number to another positive number? Huh. Shouldn't you get a positive? Carly says, well, can you reason that out for us? Why would we get a positive? And when we're adding positives on the number line, what happens? You keep going to the right of 0, don't you? Positive plus a positive. Or in other words, if somebody gives you $5, that's a positive, right? Is that a positive or not? Giving you $5. Okay. And then they give you a $10 bill. Is that another positive?
Yes.
How much money do you now have? $15. Is that a positive? Yes. A positive and another positive, when you are adding, will always give you a positive answer. There is no question to be asked. So I have an example here, 1 plus 3. And we're going to look at it with both the algebra tiles without actually having the algebra tiles physically in front of us, and the number line. So remember the little squares on the algebra tiles are the ones unit, right? What makes for a positive one? Shaded or unshaded? unshaded, or the tan when we have the actual tiles, right? So I have a 1 unshaded tile to represent the 1 in my expression. I have 3 more unshaded tiles to represent the 3 in my expression. Now underneath that I want us to combine them, because what could we say about those guys? Can they be put together? Sure they can. They're all unshaded square tiles, and all together there are how many of them? 4. So if we visualize doing it with algebra tiles, when you add tan tiles together, they're still tan in the end, aren't they? They're all tan. Bring them together. We could just combine how many we have, and we say, oh, all together here there's 4. How do we show this on the number line? Well, we start at 0, so put a little dot there above 0. And let's show going 1 unit in the positive direction. So 1 unit in the positive direction. Put a 1 above that. If we are adding, we need to keep going that direction. So we're going to start from where we left off. We're going to put a dot above that. And now how many units are we going to move? 3. 1 plus 3. So 1, 2, 3, and I put a 3 above that little line segment. And where do we end up on the number line? At 4. We follow it down to the number line and we say, oh yeah, there we are at 4. So using algebra tiles, using the number line, can you see why adding positives will always give you a positive? Is there any way possible for adding positives together to get a negative? Do you think we could ever make that happen? You'll get the math award of the day if you can come up with an example where it would not happen. You can come up with one? Carly? Oh, I didn't say, I said, come up with an example of adding positives. Can you think of any positives that if you add them together, you will get something other than a positive answer? No math boards to be handed out? Well, we could stand here all day. You could sit there all day. I guess I'm standing. And we're never going to come up with one. Because when we add positives together, we will always get a positive answer. Well, what happens what sign is the answer if we add 2 negative numbers? Is there an always we can say there? What do you think? Add 2 negatives. Well, let's just practice one before we fill that in, because, let's see if we can convince ourselves. I have the expression -2 plus -3. And notice I've given -2, I have 2 shaded square tiles. For the -3, I have 3 shaded square tiles. Can they just be put together, or are there some 0 pairs here? Are there any 0 pairs? What would make a 0 pair? Idea? Okay, so, but how would we make a 0 pair with subtracting? With a positive number. So in other words, wouldn't I need an unshaded tile to pair up with a shaded tile to 0 out? I need a positive, unshaded, and a negative shaded, and they would 0 each other out, wouldn't they? Do we have that? Do we have any unshaded ones to pair up with these shaded ones? So let's just draw them all over again without the plus sign in between. So altogether there are 1, 2, 3, 4, 5 of them, and you got to shade them all in. So because there are 5 shaded tiles now, what's our sum? What's -2 plus -3? 5? -5, because they're all shaded, aren't they? Okay. Well, let's try that with the number line now. Where are we going to start? At 0. And a -2, we would go, okay, we got to go back 2 units. There's a -2. a negative 3. Well, negative 3 is heading that direction also. So we're going to start above that, and we're going to go 3 more units and stop. So 3 units, 1, 2, 3. This is a negative 3. And we follow it down to the number line, and where are we at? Negative 5. So let's go fill in that blank. Or maybe we can't yet. How do you feel? What sign is the answer when you add 2 negative numbers? Is there an always here, do you think? Can we fill in that blank and say the answer will always be a negative? You think that's, can anybody, okay, math award going on again. Anybody can come up with a pair of numbers that are negative? But if you add them together, we will not get another negative. Anybody have it? In other words, if the temperature starts at 0 degrees and it drops, and then it drops again, is it going to stay in negative territory? If you borrow money from your parents one day, the next day you borrow some more, do they all of a sudden hand you money and say, here, you're to the good now, give you more money yet? Or are you in the hole with them? You have to earn your way out. Unload the dishwasher, clean the bathroom, something. A negative plus a negative is always going to be a negative. You can't get out of negative territory. So, those are 2 addition rules right there. We have to know those, we have to remember. Okay, we have to know that when we add 2 positives, we're going to get what kind of an answer? Okay, let's all try this again. When we add 2 positives, we're going to get a positive. When we add 2 negatives, we're going to get a negative. Thank you very much. Okay, well then, but life isn't always like that. There was, you remember Harley says, well, when you add a positive and a negative, I'm not sure you're going to get a positive. Because it says right here, what sign will the answer be when we add a positive and a negative number? Do you think there's an always we can say there? Okay, well let's play with a couple here and decide. Negative 1 plus 3. Do you see my algebra tile representation of that? Is it good? Yeah? Okay. Well, if we bring those together, let's just bring them together. One of them is shaded. Remember it says plus means bringing together. One of them is shaded, 3 of them are not. Well, what kind of a crazy answer is that? Harley?
You have to get the 0.
Okay, so you're telling me there's a 0 pair or more? Okay. So a 0 pair is a shaded one with an unshaded one. Any other 0 pairs? No? Okay, so what's the sum of these 2 numbers then? Positive 2, because we have 2 tiles left that are not shaded. Okay, let's do it on the number line now. We have start at 0. We have a negative 1, so that means head to the left. And we have a plus 3. That means head to the right 3 units. 1, 2, 3 units. There's my plus 3. And follow it down to the number line. And where are we at? We're at positive 2. Okay, give me a real life example of something that would pertain to this addition. A negative 1 plus 3. Anybody make that real? Negative 1 plus 3. 1 plus 3. Okay. I didn't ask you for the answer. We already know the answer, sir. I'm asking you for a real example of negative 1 plus 3. In other words, in this real example, we would get a 2 of something. Everybody, be thinking of an example because this is how you're going to understand these addition problems better because you can connect them to something. It isn't just some numbers and you're throwing them together and saying, huh, my pencil wants to write this. Give me a real example. I'm not going anywhere until you do. Sylvia to the rescue. You can think of money. Okay, give me an example of money then.
Your parents give you $3, and you go to the store and you see candy bar that is $4, and you get the candy bar and come home and give your parents back the $2.
So she says your parents give you $3, so you got $3. You're like, yes. You head to the store, and oh, there's this candy bar calling your name, and so you decide you better buy it. It's for $1. So you buy this candy bar for $1. You have $2 left, and you go home and so nicely give $2 back to your parents. Does that work? Yeah. Okay. Somebody else have one more? Good job, Sylvia. I can't believe it. We live in North Dakota, where the temperature changes amazingly up and down all the time, and we don't deal with just nice 50, 60, and 70 above degree temperatures. And you can't come up with an example with that. Kaden, just give it a try. Oh, now we're doing blueberries. Okay. Blueberries. We have 3 blueberries, class, okay? You eat one of them.
So then you have 2 left, and you save those 2.
Okay. So Caden says he's starting with 3 blueberries. He has a lot of self-control. He's only going to eat one of them. And now he still has 2 left. Would that work? So both of these people are giving us examples of instead of starting with a -1, like this problem does, they're instead making it into a subtraction problem, a 3 minus 1. Somebody tell me, how can 3 minus 1 be rewritten? How can 3 subtract 1? $3, spend $1 on a candy bar. 3 blueberries, eat a blueberry. Well, how can 3 minus 1 be rewritten as an addition problem? Sam? 3 plus -1. Oh, does anybody remember there's this property in mathematics that says these two can trade places? It's a property that starts with a C, O, C, M. Commutative, yes. Commutative property says, hey, you two can trade places. Well, look at there. We're still speaking the same language, aren't we? Okay, let's try this 2 plus -4. Because right now it's looking like if you add a negative to a positive, you get a positive answer. That's what it looks like. Okay, let's do 2 plus -4. I have 2 unshaded square tiles. I have 4 shaded square tiles. These are our 1 tiles. And I'm just going to bring them all together, so you do it with me. Let's bring all of them together, those 2 and the other 4. And of course, you got to shade those last 4. What crazy answer is that? Harley? -2. How did you get that, Harley? I
Took
can't
my
see
zero
-2 there. You what?
Took my 2 0 pairs.
Oh, there are 2 0 pairs. So in other words, one of these unshaded can cancel with one of the shaded. Oh, but there's another unshaded and a shaded. So sure enough, there are 2 0 pairs, and we end up with 2 shaded ones, so we get a -2 this time. Okay, let's go do that on the number line then. 2, so start at 0. 2 says go 2 units in the positive direction. So this is our 2. Plus a -4. What direction should we go for that negative? To the left. Okay, so we're going to start there at where we stopped with our first one, and we're going to go 1, 2, 3, 4 units to the left because we have a -4. And what's followed down to the number line? Well, looky there, we end at -2. Oh dear. One time when we added a negative to a positive, we got a positive. The other time when we added a negative to a positive, we got a negative. So is there an always for this one? Not necessarily. So you know what we're going to put up here? It depends. But tell me something that happened both times. What can you tell me happened both times? Whether we were doing the number line way or the algebra tiles way. Tell me something that happened in both cases. Sierra?
You both got the same answer.
Okay.
On the tiles and the number
Okay, and whether we use the tiles or we use the number line, we got the same result, okay? Tell me something with a comparison between the two problems themselves. Can you tell me anything that happened in both of them, in the -1 plus 3, that also happened in the 2 plus -4? What can you tell me happened there? Happened in both cases. Study your papers, or you can study my board, I guess, whatever you want. But tell me, between the two problems, what happened in both cases? In fact, right now, I'm going to hand out some highlighters, and we're all going to highlight after you finally come up with the answer for me. So don't take the covers off of these yet. We don't need to do anything yet. We haven't figured it out yet. Hayden?
So, there's -1 plus 3, now it's 2 plus -4. So, 1 went up 4, and got changed to a positive, and 3 went up 1, changed to
Not sure I followed that. But I tried. Don't you know that, okay? So, Hayden tried to explain to me what,
I think I followed that. I think what he was saying is from before you had -1 plus 3,
yeah?
and you just added another -1 and added another positive 1. Is that what you're saying, Taylor? For 2 plus -4.
Oh, so each time the positive, okay, yeah, okay. Well, that isn't exactly what I was looking for though, but thank you, that is a good observation. Okay, and thank you, Ms. Olson, for clarifying that. Okay, anybody else, can you tell me, because we're trying to figure out a rule here. So I wanna know, not even as much as the rule is, why and how can we get ourselves to understand what the answer should be when we're adding positive and a negative together? Because we're not doing well at this, and we gotta figure out how to do well. Okay. Go ahead and highlight with me. What can you tell me? If you don't have a good highlighter, just let me know. What can you tell me here? Danny? 0 pairs. They both ended up with some 0 pairs, didn't they? Highlight with me again. I'll get out of your way in a second here. What happened on the number line? They're like 0 pairs again, aren't they? There was like overlap. So it's kind of like we got some negative, we have the same amount of positive distance as we do negative distance. They kind of cancel each other out. They're like 0 pairs. And notice, especially on the number line, without even following it down to the number line, I want you to notice something about this right here. And I don't mean that you necessarily need to highlight this because your highlighter is going to be the same color, okay? So don't highlight now. I'm going to highlight, but I don't want you to. Tell me something about that part right there and that part right there. Tell me something about that part and its distance and direction. How much distance do I have highlighted right here? Oh, wait a minute. It starts here and it ends here. Oh, 2. And what direction is it heading? The arrow's pointing to the right at the end of that, isn't it? So it's positive. Positive 2. Tell me something about this one then. How much distance is there in my highlighted pinkish one? 2 units, right? Yep, 2. It goes from here to here. And what's direction is the arrow at the end of that one? And what direction is that? Negative. So this is a negative 2. So what can we visualize every time we are adding a positive and a negative number together? What should we be able to say in our brains? What should trigger? What should happen every time you add a positive and a negative number together? There better be some 0 pairs. There better be some canceling out. There better be some stuff taken out, right? Okay, so let's go down here now then and put some rules together. It will be a positive. So the answer will be positive, like the first one was, when the number further away from 0 is positive. So we'll go up and evaluate, make sure that we made a good choice answer here. It will be a positive when the number further away from 0 is positive. So look up here. When we got a positive 2, which of these 2 numbers is further away from 0? The 3 is further away from 0, isn't it? And is the 3 positive? Yes. And we got a positive answer, didn't we? Okay. How about we give some examples then? Give me some examples of a negative being added to a positive that's going to give us a positive result. Dan? Negative 3 plus 4, she says. Let's write it down, class. We'll evaluate if she could possibly be right, because which of those 2 numbers is further away from 0? Okay, all of us together, which number is further away from 0? The 4 is. The 4 is 4 units away from 0, and the negative 3 is 3 units away from 0. 4 is further away. So our answer should be positive, shouldn't it? Okay, without algebra tiles, without a number line, what's negative 3 plus 4? 1. How'd you get that, Danny? I know it's even hard to explain, isn't it? Or just take away 3. You don't even have to talk about the negative. Just 4. We got 4 of one tile, take away 3 of the other tile. There's going to be 1 tile left, and it's going to be positive. Why positive?
Why did you say negative?
Oh, okay. Danny can't give me another example, but somebody else can. Sierra?
-2 plus 8.
-2 plus 8. Okay, class, write it down, and let's see if we think Sierra's given us a good example. What do you think? Has she given us a good example? And why? Come on, show up. Hannah?
8 minus 2 is 6.
8 minus 2 is 6. You're giving me the answer to this already? Why is Sierra giving us a good example? What's the rule again?
It's 8.
8 is further away from 0 than -2 is, and 8 is positive, so we should get a positive 6, like Hannah said, because 8 positive tiles take away those 2 negative tiles. We're going to have 2 positives that are going to pair up with those 2 negatives. Gone. 6 positive ones left, right? Okay, one more example. One more example. Harley?
-3 plus
Can I do something? Could I do this, and does it mean the same thing? Because you all kind of got the same thing going on, and the first number is always negative. Can I do that? Do I still have what Harley wants? Barry says, no. Why can't I do that? Isn't 12 plus -3 okay if Harley wants -3 plus 12? Really? I thought back up here, you let me do this. You said this was okay because of this property called, Sam? Commutative property. You told me it was okay here, and now you're telling me it's not okay? Make up your mind. Help me out here. Can I switch that around? Absolutely I can, because it is addition. So even though Harley said it like this, they're the same thing. So what's the answer? 9. And how do we get that, Derek? Oh, wow. What did your brain need to kind of visualize doing?
I was doing 12 minus
You just took 12 minus 3, and 12 minus 3 is 9, and it has to be positive because why again? Because the positive, 12 is further away from 0 and it's positive. See how easy this is? Huh. Harley says, yeah, maybe.
Okay.
It'll get there eventually. Okay, well when will our answer be negative when we're adding a positive and a negative? When the number further away from 0 is negative. In other words, we can't get out of negative territory because there's more of that. There's more shaded tiles than there are unshaded tiles. So it will be negative when the number further away from 0 is negative. I'm going to pick on whoever hasn't spoken today yet to give me an example. Okay, that's not very many of you. Tyler, have you spoken yet? Thanks. Thanks for offering. Give me an example of an addition of 2 numbers, one being positive, one being negative, and the answer is going to result in a negative because of what we just said. Throw it out there. Come on. You got this.
-3 plus 7.
No.
Why would this, which one's further away from 0? 7. And 7 is positive or negative? Positive. So what would this give us? A positive or a negative answer? This is going to give us a positive. How about we give the negative sign to the 7 and we steal it away from the 3? You think that one will work, Tyler? Yeah, because now the -7 is further away from 0, isn't it? And so if I'm thinking of the algebra tiles, I have more shaded tiles than I do unshaded. If I'm thinking of the number line, I'm going to have more going this direction than I am that direction. So what's the answer to this? Class?
-10.
I'm going to go with this one. They're going in opposite directions. Remember, there's going to be some cutoff. 7 units take away 3 units is 4 units, and because the negative 7 is further away from 0, our answer is going to be negative. Okay. Kaylee, are you ready? Throw it out there, because if you mess up, we're pretty kind, we help.
-5 plus 2.
Negative 5 plus 2 or 3? Which, 2? Okay. What do you think, class? Write that one down. Think Kaylee's got it? Which one's further away from 0? The negative 5. And so that means we're going to do what? 5 take away 2. We're going to have 2s. In other words, there's going to be 2 0 pairs. And what's going to be left? Negative 3, because the negative 5 is further away from 0, so this is negative 3. Okay, one last one. Who's going to be the Paikia?
-16 plus 5.
Plus what? 5. Okay. Has she got it, class? How many 0 pairs are there? 5. How many units of overlap are there on the number line? No. How many units of overlap? No. 11. No. Oh. How many 0 pairs are there? 5, because there's 5 that are unshaded and there's 16 that are shaded, and so 5 of those unshaded will cancel with 5 of those shaded. But on the number line, Sylvia, can you tell me how much overlap will there be? I'm just going to have to do a little bit of kind of like cheating here, kind of like, so we're going to go. Okay, so we're going to go this way, and then I'm going to go this way, and this is my negative 16, this is my plus 5. How many units of overlap are there? 5. Just like 0 pairs, you guys. There are 5 units of overlap, just like there are 5 0 pairs going on here. What is our final answer? Negative 11. Negative 11. Okay. You will learn this, won't you? You will be good at this. You got this?